Okay, this is a supplementary lesson for lesson 61 in your textbooks. If you want, pause the video now and go to page 254 in your textbooks. I'll be going through example 61.3 on that page. Okay, so the basic premise or the approach to this problem is to remember, okay, they're going to give you two chemicals that are going to be added together. And there's two things to keep in mind, okay? The total amount of solution, okay, when we add them together is going to equal what the final is added together. And also the component parts of the solutions when added together, for instance, the amount of salt actually in the first solution plus the amount of salt in the second will equal the amount of salt in the third. Okay, let's go to example 61.3 on page 254. Virginia and Campbell had 100 kilograms of 20% glycol solution. How much of a 40% solution should they add to get a solution that is 35%? So the first thing to keep in mind, let's add the total solution together. So that will be the percentage of glycol and water together, okay? So it's real simple. The amount of solution, number one, plus the amount of solution number two is going to equal the amount of solution number three, or I call it the solution final, okay? And then do they give us any of those quantities? Yeah, they identify solution number one, we have 100 kilograms, okay? Solution number two, they're asking how much of that do we have to add? So we do not know that, okay? We do not know that. It's an unknown quantity. And the solution final, we're getting a 35% solution. Again, we do not know the actual quantity of that, okay? So let's go and look at the constituent parts then, okay? And we're going to be looking at glycol solution, okay? First of all, let's go ahead and identify how much glycol is in the first solution. 20% is glycol. How much glycol is in the second solution? 40% is in the second solution. How much is in the final solution? 35%. Okay. Now let's come up with equations that will represent the glycol solution. Okay. 20% of solution number one is glycol. So it's going to be 0.20%. And how much do we have? We have 100 kilograms. We're going to add 40%, 0.40 of how much of the solution do we have? Well, we don't know the quantity. So we're going to keep that expressed as solution number two. Okay, and then how much glycol in the final solution? 35% of the total solution final. But now, look at here, we already have set up an equation to put, if we put solution final in here, we'll have two unknowns. We'll have solution number two and solution final. Can we express the final solution in terms of the second solution? Yeah, it's right here. It's this. The solution final is going to equal solution one plus solution two. And we already know that one is 100 kilograms, okay? So the solution final, we're going to substitute SF is going to equal 100 plus the amount of solution number two, okay? But that's what we're going to put in this equation here. Okay, so by keeping track differently, total solution, that's going to be our first equation, and the constituent part, you can either pick water or glycol. I'm picking glycol in this case, okay? That's going to be the second equation. Now we set it up, we only have S2 as the unknown. Let's go ahead and do the math. 20 plus 0.40 S2 will equal 35 plus 0.35 S2. Okay, I'm going to take the S2s to the left-hand side of the equation. I get 0.05 S2. I'm going to take the numbers to this side of the equation. I'll get 15. Okay, the amount of solution number 2 then will equal 15 over 0.05. That comes out to 300. What is the units that is used? They express that in kilograms up there. That is the units we're going to use. So we're going to add 300 kilograms of solution number 2 to get a 35% solution. It's the same approach. Now, what they're going to do, they're going to give us different information on different sides of the equation. Remember, the total amount of solution plus the total amount added equals the final amount solution. Okay? The total amount of constituent, glycol in this case, plus the amount of glycol in the second solution will equal the final amount of glycol. Okay? So your two equations are going to be the total solution, the constituent part. Then we're going to use one, in this case here, to substitute into our constituent equation. Okay? It's the same process for all of those different types of chemical mixture problems. So I hope this helps. Shoot me an email or a text message with any questions. So long for now.